An object has three possible states of motion. It can be at rest, it can be moving at a constant speed, or it can be accelerating or decelerating. Imagine that three different types of fish are all participating in a race. Each fish has their own unique way of swimming, and our job is to graph their motion. Let's set up a racetrack with a yellow strip at the beginning and a flag at the end. The length of the track is 100 meters. The first fish we'll look at is a magical teleporting fish who sits at the starting line for a few seconds, then jumps instantly to the middle of the track, and then jumps again to the end of the track. In our graph, we'll assign time to the x-axis, since that's our independent variable. The distance of the fish from the starting line is our dependent variable, so that goes on the y-axis. This animation isn't very realistic, but it does show an important feature of motion graphs. When an object is still, the graph is a flat line. This graph is called a step graph because it sort of looks like the steps of a staircase. We'll name our next racer Instant Speed Fish. Instant Speed Fish will start the race with a certain speed, take a breather in the middle, and then resume its speed for the remainder of the race. Instant Speed Fish does not need to worry about accelerating or decelerating. It can reach its desired speed immediately. This animation is a lot closer to reality than the teleporting fish, but it's still not quite right. When the fish takes a break in the middle of the race, the stopping and starting is really quite jarring. If this were a real fish, it would have to slow down to stop and then speed up to get moving again. The final racer is called Real World Fish. This fish can't teleport or reach speeds instantly. It has to accelerate and decelerate just like a real fish. This animation is definitely the best so far. The motion is very realistic. We see the fish accelerate at the beginning, swim at a constant speed for a while, then decelerate to zero. When the fish is finished resting, it accelerates, swims at a constant speed, then decelerates to the finish line. To summarize, we can represent the motion of a fish on a graph in three ways. We use a flat line if the fish is motionless, we use a straight slanted line if the fish is moving at a constant speed, and we use a curved line if the fish is accelerating or decelerating.